This course is on the principles of safe software design. Now, software safety can be a daunting subject. Software, big challenge, as we will see, very risky business. Safety, also intangible. People are nervous about it. So you may look at a subject and go, oh, how could I possibly get into software safety? How do you develop safe software? It's just too difficult. I don't feel confident to even try. But it need not be so. In this course, I'm going to talk about some things that introduce the principles of safe software design, but also the things that go around it to help you understand what software safety is all about and what it isn't. So the learning objectives for this course are top level, they're here. We need to understand that normal software development is about trying to get the job done, which is fine, trying to get a project over the line before we run out of cash. But that's not in itself going to lead to safe software. That's a very different problem. But the good news is, if we understand how software really causes harm to people, then the solutions to that problem become quite obvious. And they're not as difficult and as technical as you might think. Those two first sessions are free, by the way, so you can try them out before you buy the course, if that's where you choose to go. The first part where we get into the course proper is we're going to look at this concept called the 4+1 principles. And this is a subject introduced in an academic paper, which I quote and refer to, about the 4+1 principles. And what these allow us to do is to look at all different software development standards, and they give us a framework for understanding how those software standards prevent software doing harm and what their strengths and weaknesses are. They enable us to understand software standards and evaluate them using the 4+1 principles. That's the core of the course. But also we need to put more around that. Having understood how software really causes harm, well, standards are part of the solution, but by no means all of the solution. So we need to understand the limitations of standards and compensate for them, add extra stuff on and understand what we're really doing with standards. And we need to learn lessons from real world software failures. And as I said before, the answers to preventing computer-related accidental death are not necessarily as technical as we might think they are. What's in the course? We've got these sessions. First of all, we've got a brief overview of software development as it really happens in the real world. And then we contrast that with some facts, not fashion, about software safety. Because unfortunately, software engineering has been for many years subject to fashion and still is. But actually, the fundamentals do not change. The fashionable fads that come and go are usually irrelevant. So those first two sessions are free. You can try them out. Then we move on to what are the safe software principles, those 4+1 that I mentioned. Now, before we can apply them to standards, we need to understand how software safety standards really work. And I'm going to, in that lesson, I give you an overview of how they tend to work and the way they are built up. And then that will enable you to benefit from the next session, which is where we actually talk about applying the 4+1 principles to get safe software, and most important of all, applying real examples of where it's gone wrong. Because this is one of those things, it's easier to illustrate by examples what we really mean than to actually talk about it. You can talk about things in the abstract all day long, doesn't necessarily help. So we look at some real accidents and what caused them. Then we get on to the guts of looking at 3 examples of standards. So first of all, we have DO178C, which is a commercial aviation software standard. We look at IEC 61508, which is a family of functional safety standards, and that's very common in the process industries, and also there are versions for safety instrumented systems, rail and so forth. And then finally we look at ISO 26262, which is a derivative of 61508, but it's aimed at the automotive industry, and that one's very popular and very in focus at the moment. It's good to cover that. After that lesson, our penultimate session is a review of those standards. So we pull them all together and use the 4+1 principles to evaluate them. We've already done each standard one by one, but let's pull them together and look at some themes. And then the final session is lessons learned more broadly, not just about standards, not just about the 4+1 principles, but the bigger picture. And then the final session is not a lecture at all, but it's a download of the presentation slides, so you've got them for reference. And I also want to mention that at every stage for every session, there is a quiz. So you do a session, well, they're all quite short. You do a quick quiz to check your understanding. Maybe if you're confused, go through the session again, and then you can move on and go through. The quiz is there to reinforce and test your learning, and I think that will help you to really grow in confidence and know that you've taken in the information. So this is all very well, but why should you actually listen to me? Well, my name is Simon Danucci, and I've been in the software safety business for a long time. As you can see, I started my first job in software engineering was back in 1994. I don't want to think about how long ago that was. And then I got into system safety engineering in 1996. I've worked in software safety on and off since then. Now, my roles that I've performed, I've been mostly involved in aviation, as you can probably see from the pictures on my study wall. I've done fast jets, surveillance, reconnaissance and EW platforms, and helicopters. I've also been involved with ships, submarines, information comms and technology, ATMs, not hole in the wall cash machines, it's air traffic management. I've done some rail and some road vehicle work, but not a huge amount. Most of my working life has been with aviation and maritime. Now, I've worked, as you may be able to tell from my accent, I'm from the UK. I had a career in the UK. I moved to Australia 10 years ago, but I've worked on a lot of US programs and quite a few European collaborative programs as well. I've seen a lot of different ways of doing things. And the roles that I've performed, well, I've worked on the customer side. I've worked on the supply side from those who are actually producing the stuff. I've worked for a long time as a consultant. I've done DevOps. We didn't call it DevOps back then, but that's what it was. We had a software team with a customer requirements team all merged together in one, and that was fantastically productive and successful. I started my career in that, and I come from an integrated logistics support background. I'm also familiar with logistics support analysis for software and all that involves. A wide-ranging career, and currently I am system safety lead for a major company, and I'm still practicing. I'm still doing the job. I'm helping other people do the job. I'm checking their work. I'm a trainer, not just here, but in day-to-day work, and a mentor of young system safety engineers. And I'm very proud and enriched by doing that. My desire is always to help people come along and enjoy a great career as I've been so lucky to do. Now, there's one thing I want to say. This is not a course about coding. So if you're here thinking that I'm going to teach you how to do coding for safety applications, that's not going to happen. As you will see, it's not really about coding. Yes, software has to be coded, but actually the safety game is won or lost long before we get to coding. If we haven't addressed safety in the requirements and in the architecture and in the design, then it's too late by the time we get to coding. So no amount of clever coding can fix that. If the requirements are bad, you're stuffed. It's game over before you've even started. And that's what I'm going to go through in this course. So not about coding. Years ago in the mid-80s, I taught myself to code BASIC and assembler. And since then, I've learned Fortran and Coral 66 and Ada and other languages, but I'm not a programmer. And this is not about coding. Thank you for listening to this brief introduction. And I invite you to continue to the first two sessions, which are free. So you can check out what I've got to say before you shell out any of your hard-earned dollars. Thanks very much.